Alright guys, welcome back. This is lesson 10.4. On this one, I want to focus on Pythagorean theorem and also the special right triangles, but I want to focus on breaking down the radicals. So on the last lesson, we just hit the square root and we got a decimal answer. Now I want to practice, like right here, when we were trying to get x by itself and we took the square root of both sides, I want to review how you break down the square root of 80, okay? You guys remember how to do that? Basically, you're looking for a factor of 80 that is a perfect square, okay? And you hopefully can find the largest one. The largest one makes it quicker to break it down. So my brain pops 16, because 16 times 5 is 80, okay? Then you separate the perfect square from the non-perfect square, and then the square root of 16 is 4, and then you leave it as 4 radical 5, okay? So that's how you break down a radical. So we had already done question 1 before, but we got the decimal answer, and now we're just breaking it down and leaving it as 4 square root of 5. So why don't we practice a few more radicals just to make sure that we're good, okay? All right, let's just practice a few more, and then I'll do one of the special right triangles that I did on the previous lesson, okay? All right, so let's just break down another one. Oh, I know a good one that they love, okay? Let's say you have the square root of 98, all right? You can literally just take your calculator and just start dividing by perfect squares. I immediately saw that was even, so I thought, okay, let me divide by 2 and see what I get, and it's 49 times 2. You separate the perfect 49 from the 2, and this is just 7 square root of 2, okay? So our focus, same thing, but we're going to break down the radicals and not put a decimal answer. Okay, a couple other things that I need to review with you. It's been a while since we've done this. What if you're dividing by a radical? So this is not simplified because you cannot leave a square root or a radical in the denominator, okay? And there's this method of getting rid of that called rationalizing the denominator. And all you got to do is multiply the numerator and the denominator by that same denominator. So whatever this radical is, you multiply the top and bottom by it. The top's really easy. It's just your coefficient times that radical. And then a radical times itself is just the radicand and the number inside. Okay, if you don't like the way I said that, I kind of get that. This is the same thing, the square root of 2. That's my only audience now. My only audience is 3 dogs. Remember, that's the square root of 4, which is 2. And yes, as ugly as that looks, that's how you leave it. Wait, what's that? No, I know you're tempted. You're tempted to drop those 2's, but you cannot, okay? This is a 2. This is a square root of 2. Remember, this is like $1.41. So $1.41 is not equal to 2, so you cannot cross those 2's out. You're going to leave it like that. Okay, so let's find that one that we did on the last lesson, and all we're going to do different is we're going to use breaking down the radicals. Yeah, I know which one it was. It was number 7. Remember number 7? And hopefully you guys can hear me. It's got to be a delivery. Yeah, okay, here it is, number 7. So this is the special right triangle, either 45, 45, 90, or 30, 60, 90. But look, this is 60, this is 90, so this has to be 30 degrees. All right, let's label. Jump across 30, shorter leg. Okay, jump across 60, longer leg. Always the king is across from 90, that's the hypotenuse, that's H. All right, your little reference sheet, remember, it is short leg, longer leg times the square root of 3, and then hypotenuse is double x. Always go in order, small, middle, the king, the largest one. All right, you remember this problem? 27 was the longer leg, so I'm going to put it over here. Okay, but now we're going to keep that square root of 3, square root of 3. So you got that one-step equation still. You guys know how to do this. Okay, I'm going to divide by the square root of 3. I'm going to divide by the square root of 3. All right, this is not simplified because you can't have a radical in the bottom. So you have your x over here because these are completely identical. They're both square root of 3's. But over here we have to rationalize the denominator. So you're going to multiply the top by the square root of 3, and you're going to multiply the bottom by the square root of 3. When you do that, the new numerator is 27 square root of 3. And remember, a square root times itself is the radicand inside. Alright, and then look, the 3 is outside the square root, the 27 is outside the square root, so you can simplify that and make that 9. So x is 9 square root of 3. And that comes up here in your chart. Okay, so x is 9 radical 3, we were given that one, and then whatever x is, you're going to double it, so you're going to double 9 square root of 3, let me slide this over, and you're going to get 18 square root of 3. I hate these x's and y's, okay, those are just so they can label it on here, but either way, 18 radical 3 is the hypotenuse, and then 9 radical 3 is the short leg over here. And they're just calling this one x, and they're just calling that one y. So x is the hypotenuse, 18 radical 3, and y is the short leg, 9 square root of 3. Okay, listen, don't give up on me. I need you guys. Hang in there. And don't forget, we have a Zoom conference on Wednesday at 11 a.m. Please join me for questions. All right, take it easy.